Good morning, everybody, and thank you for joining today's IPC webinar, Adopting Traceability for Your Supply Chain, the Rewards of Assessing Your Risks. This webinar will focus on the new IPC standard on supply chain traceability, IPC-1782, standard for manufacturing and supply chain traceability of electronic products, as well as the benefits of establishing traceability to protect your products and brand. Before we begin, I want to touch base on a few housekeeping items. First, if you have a question during the presentation, feel free to enter it into the chat window. Time permitting, all questions will be addressed at the conclusion of this presentation. Once again, I'd like to thank you for joining us today, and I'd like to introduce our presenters for today's webinar, Cameron Sheeran and Michael Ford. Cameron Sheeran is Lead Quality Engineer in AT&T's Global Supply Chain Group. Cameron also worked in AT&T Labs as part of the group that defined the hardware reliability requirements for the devices AT&T sells in its stores. In his current role, he works with a wide range of people inside and outside of AT&T to develop a standard portfolio of metrics and structure for those metrics, along with an associated governance structure for the new global software-defined telecommunications network. Cameron initiated and chaired the development of IPC-1782 with the encouragement and support of his leadership with AT&T. In addition, Cameron has a semiconductor and semiconductor processing background, as well as a decade of failure analysis and product safety engineering work. He received his bachelor's and master's in material science and engineering from North Carolina State University. Michael Ford is Senior Marketing Development Manager with Mentor Graphics Valor Division. Working in the Valor Division provides Michael the opportunity to apply his 30-plus years of experience in the industry to identify tomorrow's solutions based on evolving needs in the market. With a degree in electronics from the University of Wales Institute of Science Technology, Michael started his career with Sony, gaining experience of hardware, software, IT systems architecture, and a broad range of manufacturing skills, leading to the creation and management of Sony's global lean manufacturing solutions. Since joining Mentor Graphics in 2008, Michael has become a key contributor to thought leadership in the industry, predicting trends and bringing insight of opportunities, driving the evolution of manufacturing execution technologies that deliver direct business benefits. In particular, Michael has established industry thought leadership in the areas of the Internet of Manufacturing, Industry 4.0, and smart factories, as applied to electronics manufacturing. Michael also works towards establishing key industry standards, including the revolutionary Open Manufacturing Language, OML, as well as working with the IPC as co-chair of the IPC-1782 Traceability Standard. Before introducing our first speaker, I just want to let everybody know we're having a little bit of audio issue with Cameron Sheeran. We hope to work that out shortly. But for right now, I would like to turn the presentation over to Michael Ford.
Okay, thank you everybody. Thank you for attending today. I hope that we're going to bring for you a valuable insight into a kind of new way to approach traceability, a new standard from IPC, which is actually the first standard really dedicated toward electronics traceability. So we'll let the story unfold. So if we go to the next slide. The first thing that we need to ask ourselves, just to make sure that we're all on the same page here, is what is traceability actually? Now, I guess when most people think about traceability, they go to a technical point of view. And for sure, traceability will be the complete build record of a product. That is starting like with a bare PCB coming into the operation, several operations to place components, manual assembly, test, inspection, all of these different kinds of things will happen. And so we're collecting information about that product as it's manufactured and, you know, the flow of the product through manufacturing. So a lot of data is going to be captured. Now, some of this data is going to be related to the materials that were used, and some of it's going to be related to the processes themselves, how they're set up, kind of test results and stuff like that. So that is kind of most people's impression. We're going to be collecting a whole load of data from all over the shop floor, and okay, that's going to be all put together to give us this complete build record. And I guess in most people's experience, this has kind of been done in the past to the present day with varying degrees of precision. It depends what kind of data is required, what kind of data is available, and to what purpose we want to use the information. So that's the kind of technical point of view that most engineers will come forward with. However, traceability has a completely different value when we consider the business point of view. So first of all, we look at management assurance. We see quite often that there is some mandatory data to be collected according to the way a customer, for example, of an EMS company may mandate, okay, this needs to be done, this needs to be stored, as a kind of assurance that the product is going to be made according to instruction. Sometimes, of course, we hear stories in the media about recalls that are done on various products. And, whenever a significant problem happens in the market, the manufacturer is the first one that comes along and is being asked, well, did you cause this problem? And traceability information is a very useful tool to say, well, actually, no. Actually, the materials you said should be used were used, the process you said should be done were done, and so, okay, I am now, not having the responsibility for this problem. So it's a kind of an insurance policy, in fact. But of course, nobody expects or plans to make such market problems. So, sometimes this is a kind of reason which we hope isn't going to happen. One of the more interesting applications for traceability is for quality control. And we're going to be seeing that with a full set of traceability data, this can bring a step change improvement of the way in which quality is managed. Even those one-off defects that we've never been able to explain could actually be explained when we look at the complete set of traceability. And with all of that information comes accountability. We don't just want to say as a manufacturer, hey, it's not my fault, I don't care. Really, we want to say, we understand what happened, and we found that maybe the responsibility lies with the supply chain, or even with a design issue, or potentially a manufacturing or process issue. We want to know this information so that we can improve in the future. So this is what traceability is all about. Next, we're going to have a look at what people's perception of traceability is, which actually can be a little different. Because you can say the word traceability to a lot of people in manufacturing, especially those involved in, for example, automotive, medical, and aerospace, and they will tell you that traceability is actually a burden to them. It's all very well wanting to know all of these different pieces of data, but it introduces a huge amount of additional work, and that has a cost associated to it, and it even disrupts the operation. So really the idea is to minimize the kind of data that should be collected, because that will then minimize the cost and disruption. So, anything additional that we bring onto the table, like, oh, we would like to do this for quality, or we'd like to do this for some other purpose, there is an associated cost and therefore an associated resistance. People sometimes think that, having too much information there is like Big Brother watching them all of the time. So whenever it comes to deciding what is appropriate for traceability, it's kind of negotiated between the customer and the EMS company, or even internally between the OEMs for their factories. And it's never a good thing. Quite often, we end up with some expectation which is unrealistic. Sometimes we end up where the information is not complete, it's not the right information, maybe it hasn't been put together well enough. And in fact, in some cases, we end up collecting too much data and spending a lot of money that maybe we needn't have bothered doing. This is people's perception of traceability, and I cannot tell you that it's wrong. We've seen case after case of this kind of thing happening, and the whole thing has been a complete mess for many, many years, especially in electronics, because for electronics we have quite a complex bill of material and a very complex set of processes. So more than any other industry, pretty much, this is a real pain point for the whole operation. So next, we'll look at why we've now suddenly decided to create a new standard. So IPC-1782, important to remember that number. We're going to be seeing a lot of it. There was an issue a couple of years ago with some memory chips in the market in the US. Now, these were chips that were kind of used in many, many different products. And when a problem was found with them, it was an absolute nightmare trying to identify those products that may had to be repaired or may was suspect. And so, you know, the cost and the resource that was necessary to do that, it was just unbelievable. So some of the guys involved decided, okay, it's time now to create traceability, because instead of having to recall all of the devices that could potentially be affected, we want to know exactly which devices were affected. And so this is when Cameron went to the IPC and started the discussion to build this first consensus-based traceability standard for electronics. So here's the milestone, the first.
Mike, I was just going to say, we wanted to, like your last bullet there, we wanted to make sure that we had a good trade-off between the traceability values and then compare it to its relative cost, so that people could associate, in other words, different levels, which we'll talk about later, with what's appropriate to the level of risk that they actually have in their for their particular product, and also being able to convey that information across businesses. So if there is an issue, then you'll be able to pick that up without a lot of disruption.
Okay, Cameron, if you'd like to continue from there.
Sure. Chris, can you go to the next slide? So what we tried to do was to because it is, like Michael said, there's a lot of history to it and a lot of misperceptions, and what we wanted to do is to ensure that we had a very robust and well-rounded standard, and so we included a wide range of companies. You can see them here, and I'm sure a lot of them are participating or as attendees on this call, so we want to thank each and every one of them for their inputs to make it a very successful standard, and to provide their perspectives on it to ensure that it would be a useful standard. Chris, you're welcome to go to the next slide. To provide some guidance to companies, we provided a risk assessment tool that's based on the MIL standard 882-D, and you can see that it's like any risk assessment tool. It's based on the severity in combination with the likelihood or probability of an event occurring, and we provided that, like I said, as a guidance scenario, and we correlated that with, provide some guidance so that people could actually say, okay, well, here's the risk and what level should I be at, and again, that's just for guidance. Ultimately, it's a voluntary standard that it's a negotiated piece between a supplier and a customer. But anyway, that's all I was going to say. You're welcome to go to the next slide. And also, we had a request that we wanted to correlate with the traditional IPC classifications versus the traceability pieces that we had, since we were looking at both process and material level. And so this was a decoder ring, if you will, that you can use to go between the traditional IPC classifications and our intention for use in the IPC-1782 standard. And again, you can see how it maps to each level. And of course, exceptions can be granted based on an agreed upon between a supplier and a consumer of that material. And so we just put good, nice breakpoints, mile markers, and people can use those as budgetary planning tools, and then also negotiate off of those. Just makes it easier to make them actually, as a starting point, and have some uniformity so that the suppliers can match to work towards one unified, coherent and collaborative standard. So, Chris, that's all I had. I appreciate the opportunity.
Okay, thanks, Cameron. As we've seen with the kind of assessment of risks, etc., we're involved in so many different sectors when we talk about electronics manufacturing. I mean, we could be making a USB drive, for example, in China, and the business is not going to tolerate having huge amounts of data collection for something which is probably not realistic. On the other hand, maybe we need higher levels of traceability, for things like automotive or medical devices. And so what is appropriate? And as we've seen, when we've done the analysis and the risk, etc., we are then left with the requirement that we'd like to fulfill. And so within the standard, we came up with 4 different levels. And these levels were designed such that everyone who is making electronic product can go through the processes we've just outlined and be able then to see which is the appropriate level for them to adopt. And these levels are divided between both materials and process. So let's just go through the basic levels. Level 1 is in fact basic. The kind of intention for level 1 is that, we would see that pretty much everybody in the industry today should be at a level where they're having some kind of due diligence over what they're doing and what has actually been done. And so we read down the column, we see that for material traceability, for example, we understand which part numbers were listed for this work order, so we know what materials were used on a work order basis. Going down to the process, we would expect the basic level to include a list of some very significant processes or exceptions that happened during the work order. For example, maybe a particular quality issue was found and was resolved, that kind of information. The levels don't just define what information to collect, though. It also defines the kind of integrity of the information. And we see that a lot of people these days, as a default, are really collecting information manually, kind of ad hoc information about the line. And so we also wanted to be able to define the integrity that would be associated with level 1, which would be 3 sigma in this case. We also, we understand that maybe 90% of the data is going to be collected manually, and so, we want to allow for that. And, by doing that, if we're putting the data into a spreadsheet or a database or something like that, it could take some time to get a kind of report. For example, if something were to be queried, what material did you use for a certain work order? Okay, it's going to take a little while to get that data together. Data retention time is a very key attribute of traceability. But, for the basic level, we would probably keep the data for the life of the product, during which the time it's being produced, and plus 1 year after that. So this is kind of the basic kind of category that, people we would feel should be doing right now. Level 2, on the other hand, brings in a kind of higher granularity of data. If we were to look at the materials, for example, now instead of just listing part numbers, we are looking at actual unique material IDs. These are ones put on reels or on boxes or bags to be able to identify the kind of path of that material, the usage of that material throughout the whole operation. And so this means that we have a much greater control, because that material ID is going to tell us things like who was the actual vendor, what was the GRN number, what date did it come into the operation, etc. So we're able to get a much higher degree of granularity. And for process traceability also, we would expect to have a serial number on the circuit board itself, whereby we could then understand the exact materials, for example, that were used for each PCB, and also the test result according to each PCB. So you can see that we're collecting now data on a PCB basis rather than the work order basis. Now, we don't need to have both material 2 and process 2. You could, for example, say, well, I'd like to have material level 2, but process level 1. And maybe later I'll go to process level 2. So, all of these levels can be mixed and matched. So again, with level 2, we see a higher degree of data integrity, more automation in the way that data is being collected, because now hopefully we're being connected to machines, and that means that the reporting should be more efficient. And because this is a higher level of traceability, it's probably associated to a higher class of product. Therefore, we expect the data to be retained for a longer time. Level 3 we call advanced. Here is where we start to add a lot of processed data coming from the different test processes. So not just a pass or fail that we might expect in level 2, but actually some of the characteristics that were reported by the different processes. And within the standard, we go through all of the different types of processes, and we list for each of these levels what kind of data fields are appropriate to be collected against them. For level 4, this is basically we go all out. We are collecting every possible metric. The materials that are used, this is actually exact to the reference designator level. So, machines need to be able to communicate that, on the 5 references from the same part number, which ones came from each serial number of material. So that if, for example, the material was changed halfway through the board was made, then that has the record of which reference designators were from the old one and which reference designators from the new material. So we've really gone out to very, very high accuracy of data collection. And so level 4 we would think is appropriate only to the very highest levels of requirement. And as we can see there, the data integrity has gone up. The data collection we would expect to be fully automated now, and the reporting is basically instantaneous. So the whole thing is a live system which is running alongside the production process itself. So these different levels, we've got some from the basic and standard. It means that any operation can adopt the standard without it being a sudden shock to the system. Okay, maybe a lot of people will start out at basic, even though maybe they're making class 2 or even class 3. And, it gives a little bit of time for the adoption, for the collection of the data to be set up, for the reporting and the database to be put into place. People do need time to get to those levels. So this way, we're offering the ability for people to start at a place and then work their way up. Okay, next, we're going to have a look at how the data is actually stored, because you can imagine that if you take a finished product, for example, that's normally where something would end up in the market. You have a problem with a particular product, you look at the serial number on the box, and then you want to be able to work out what's inside. And so what we did, we created a kind of tree structure, which is a kind of it's a root structure actually. It kind of follows then down to all of the different components of that assembly, that final product. And so in the case of a final product, we would have 2 kinds of information. First of all, there is the work order. And this kind of defined what were the production processes through which that product went through during its final assembly. We would have the bill of materials, which would include all of the cables and screws and boxes and packing materials and all this other kind of stuff. But of course, maybe one of the components would be in itself a subassembly, which itself had its own production line and set of traceability data. So we've kind of created this hierarchical structure so that we can then associate the subassembly, which is the PCB, together with a final assembly. Even the PCB subassembly may have another subassembly associated with it, and so the root structure goes down and down. And we can see that the main components, the work order and processes, for the bill of materials side, we have a look at all of the different materials down to the raw material level. Any material that comes in which is uniquely serialized, for example, it could then be interpreted as a subassembly because it has a history of materials that went in to make that material, and we see again the information about the processes. So this kind of hierarchical structure is quite important to be able to put together like a jigsaw the complete information about a particular product. It could be, for example, that a hard disk was used within a product, and that was made maybe overseas somewhere. And so actually you can get a set of data that would represent that assembly cell. And you could simply link it then to the final assembly, so that then you have the complete traceability structure. So it doesn't need to be made in real time during manufacturing. It can actually be pieced together, and it can actually reference different pieces of information across the world if that is how your operation works. But normally we would expect it to be on site. So that is kind of the modular approach there. The other interesting thing to remember here is that a reel of 1,000 components, let's say we understand some information about that. But those 1,000 components could potentially be used in 1,000 different products. Now, we don't want to have a traceability record repeated for that piece of material in all 1,000 assemblies. Suffice to say that here is the information for the material, and we reference it 1,000 times. So again, this kind of structure, this cellular-based structure, ensures that we capture that information once, and then we reference to it through as, for example, each occurrence of that material being used. So not only did we want to have the structure following manufacturing structure, we also wanted to have the information stored very, very concisely. And in fact, using this kind of indexing mechanism, it enables the data size to be even 1,000 times less than what it would be if you had associated all of the traceability data with all of the individual products that were made. So, we want this to be very easy to manage. We want it to be easy on resources, something that is practical to be used. And this kind of architecture is actually very suitable for big data applications. So, we can send all of this data up into the cloud, and it's there for people to use. Okay, next we're going to have a look at the availability, well, actually the enabling technologies behind this standard, because for many years, at least when I started, I was talking to automotive people, they were literally writing things down on bits of paper and storing them in warehouses. It was absolutely ridiculous. Now, of course, as time has gone by, we are already able to collect information from the various processes that we have. For example, SMT machines. Pretty much every single SMT machine on the market now has a way of gathering that data. Okay, there may be some machine vendor software to put together. You may need to link that to a database, and you can then start that flow of information. And a lot of the operational information, like machine start and machine stop and the test results, this kind of information can be gathered. The more that we actually collect through automation, then the higher the integrity of the data, because we're not going to be making so many mistakes. The IPC, we're looking also at the Connected Factory Initiative, that is to create an environment in which data can be gathered from these machines. So this is one of the kind of follow-on exercises that we're doing. But there are other standards already in the market which allow this kind of information to be gathered. And so, as time has gone on, it has become much, much more cost-effective to be able to gather this data automatically. And this has really been the thing that enables traceability to happen now at a much more cost-effective basis than before. The other kind of area of cost for traceability is in the receipt of materials. Typically, or at least historically, getting materials in from suppliers, being able to read that into ERP, into MES, trying to understand what all of the materials are, ready to put them away. It can be quite a difficult task, and it's a manual operation. And if we're expecting here to start to serialize all of the reels of materials and bags and boxes, surely that's just going to add more cost to the operation. Now, we want to reduce that cost. And so, as again, a kind of spin-off from this activity is that we would like to have materials being marked electronically such that you can read them and then automatically transfer information about that material to generate a barcode label and to populate the traceability database. So different standards are already in existence, but these kind of, again, they are in different areas around the world. Different groups have made different agreements, different suppliers and different companies. It would be nice if we could get to an overall standard, and that is something that we shall look at in the future. But certainly being able to derive information directly from materials using even the existing barcodes that suppliers put on really has enabled the more rapid and more cost-effective introduction of materials into the operation. Okay, let's move forward to the next slide. Now, I guess what we're all thinking now is, this sounds great. We've kind of come along with a traceability standard. We've defined the kind of data that we want to keep. And, you can have a look at the standard as published. We'll be sending you a link about that after the webinar here. And you can look for yourself about all of the different processes and all the different kinds of data to be collected. So let's go through some examples, though, on how that data practically gets used. And this will give us a kind of idea on what we're talking about for the application of traceability. After all, we've been talking about some of the costs. Let's start to talk about some of the benefits. Now, these three examples that we're going to look at, I can't say that they're 100% positively true in the fact that there was a company that had this exact problem, but these have been compiled from genuine cases, but from different companies piecing together as examples of how traceability has been used in the past. So the first example we've got is an airbag. Very critical piece of equipment. We do not want to be hitting brick walls without our airbags. Now, during the long-term testing at a manufacturer making the airbags, they found that there was a failed component in the deployment controller. Very, very nasty scenario. It means that there was a potential for the airbag not to deploy when necessary. So the engineers immediately went to the traceability data. They needed to find out the pattern of instances of this failure. They didn't know where it was, but they needed to start to narrow it down. Was it a kind of a process-related problem, or was it a material-specific problem? Some guy suggested it looked to him like that part was susceptible to ESD, and so they kind of thought that might be the problem. But they had no idea about the scope. They knew that, these products that were being tested, they've been sold already into many cars, but they had no idea which ones without the traceability. So next, we'll have a look at what we can do in that scenario with the IPC data. If we go to then, yeah. So this kind of scenario, what would happen? Now, without any traceability at all, so without IPC-1782, the guys would have found that, yeah, okay, we've got this problem. We know it's related to production around a certain time period, and so therefore that the airbag controllers that were kind of distributed at that time, they could be in any one of 400,000 cars. Okay, so next thing you see is big signs in the newspapers, announcements, 400,000 cars being recalled. We see these headlines over and over and over again. It's a nasty scenario. The kind of issues for the brand, the cost, people's impression about the cars they're driving, people's concern. It's really a nasty thing to happen. But, without traceability, that's what you have. You have 400,000 cars that may have this controller that may not go off when necessary. If instead IPC-1782 Level 1 had been implemented, we would know a lot more about that range of cars that were affected by this. And we would typically see that 400,000 number reduce to 15,000. Okay, we're still having to do a public recall, but the cost associated with that is going to be a lot less. Now let's go to level 2. Now this is where we're recording all of the process information about specific PCB so we can trace back and find out exactly where the faulty units had gone. And the engineers who were doing the testing, they found that a common factor had occurred for the units that they found as faulty. They found that a specific inspection station doing a specific shift had been the common factor. When they checked the records in production, they found that actually a faulty earth strap had been detected, but it was replaced, but actually no other action was taken. So they didn't realize that whilst the strap had been faulty, actually units were getting damaged. But they knew exactly the time period, they knew exactly the product, and they were then able to state, okay, we have 992 faulty units that potentially pass through here. Now, instead of doing a public recall, we know exactly which 992 cars they are. We can write to their owners and ask them to bring their car in, have a free service, have the car upgraded. Okay, we want to be upfront about it. There is a kind of a problem for a recall, but it needn't happen in the newspapers. And my own car actually went through this process. A certain manufacturer in Germany was able to use this level of traceability, and they knew exactly which cars needed to be recalled, and they gave me a good service, and the car was actually cleaned, which made a change. And it's a much more pleasant experience than reading in the newspaper that your car is about to kill you. Level 3, level 4, it's actually been cut off there a little bit on the slide. Apologize for that. In this higher level, we're able to actually pinpoint even fewer cars. I think it's about 990, in fact, because we're able to pinpoint more accurately the actual units. But the lesson to learn here is that without traceability, or even with a very low level traceability, we're only able to identify a huge number of cars that could potentially have the potentially faulty unit. Whereas with the higher level of traceability, we remove a huge amount of cost, we remove a huge amount of heartache trying to get things sorted. Okay, if we go to the next example, because, after all, who was planning to make a faulty airbag controller? It's not number one on our wish list. It may never happen. If it never happens, where's the value? So instead of that, let's have a look at another application of traceability, quality and product safety. So in this example, during manufacturing, they were making 1,000 medical devices, and everything was fine until a defect was found at functional test. Okay, so they found at the repair station that an SMT device was a little bit twisted. The contact with the pad had been made, so it passed ICT and all of these other tests. But then when it came to a functional test, the actual connection had failed. Okay, so the question was, these 1,000 devices were made at the same time on the same pieces of equipment with exact same materials. Nothing changed. How come we had one device that was faulty and yet all of the others were absolutely perfect? And so the objective of looking through the traceability data is now to try to find the deviations. So there may be subtle deviations in the process that, in isolation would not be a problem. But maybe 2 or 3 of them happened at the same time that caused a unique condition that caused this defect to happen. So it was nothing that anybody could have kind of predicted. But once you know that that can happen, okay, we can try and make sure we'd never have that condition again. Now, of course, the production manager, he's coming along and says, hey guys, you've got a one-off defect. Does this mean that I can ship the rest of the work order? Or do I need to wait until we found the exact cause so that we can be sure that all of the others don't have this same weakness? And so we can have here a delay of delivery to the customer. If we go to the next slide, we'll see about what happens with and without the different levels of traceability. Again, in this scenario, without traceability, you're basically going back to manual management and engineering quality practices, which are good. They are tried and tested. However, there's usually a less than 20% likelihood that you'll actually find that one-off defect cause, because you just don't have the information. You can look at as many things as you like, but it's too late. And quite often, for a critical kind of product, it can mean a delay of the shipment by up to a week. This is what we found in this kind of area. If, however, IPC-1782 at level 1 or level 2 had been used, then we would have seen the data showing that the right processes had been executed, the materials had been used according to requirement, and so that will help us a little bit. To be fair, we will maybe see that everything was good, but it doesn't really help us find the root cause of this problem. So this is where we need the higher level of traceability. levels 3 and levels 4, which are collecting the kind of results of processes and also the status of processes as the different products are going through. So for example, in this case, with level 3 or 4 traceability, the analysis of the data would have shown, for example, the screen printer just gone through a cleaning cycle. Interesting, because the first one after that may be a little bit uneven. Maybe, for example, there was a little bit of extra thickness where normally there wouldn't be. In itself, not a problem. It's a very, very small thing. It doesn't matter. However, in this case also, the material that was placed there was from an alternate vendor. Again, that's not a problem. That part had a slightly reduced height compared to the normal one, which normally is not a problem. But we're putting those two things together and we're placing the part with a lot less force than we thought. Maybe even that would not be a problem. But in this particular case, the reflow oven temperature was slightly ahead of the profile, so it's slightly hotter than it needed to be. It was within tolerance, but together with these other problems, it caused that component to float a little bit, and it started to rotate. Because we have the traceability, because we've got that evidence in front of us, we can now see that that was a unique situation. We know that none of the other products had that. This was very likely to be the cause. And for sure, we can repair that product now and confidently ship the work order. But also we can go back and we can actually put some improvements into the process to make sure that that problem will not happen again. Let's look at a third example in the next slide. This is to do with the increase in the occurrence of counterfeit materials. Actually, one of the things coming from the group doing this standard has been some amazing kind of stories about counterfeit materials. Unbelievable. Sometimes we see, as in the picture, labels have been rubbed off, some other ones have been etched on. I mean, this kind of thing happens. We've seen cases where, for example, you get a reel of materials that got 1,000 pieces on it. The first 100, absolutely genuine. So where that went into an incoming inspection, take a few components off, test them, no problem. But after the 100, every 7th one was counterfeit. How on earth are you supposed to test for that? You would have to test every single part on the reel. So this counterfeit issue is becoming really serious now. And I suspect that we're seeing a lot more of it, not necessarily because counterfeit is increasing, but because more people are actually looking for it than they did before. So this example is about a smart heating controller. You know, they'd been making many of these. It was a hit product in the market, a lot of people buying these smart controllers, and sometimes, however, they were having some random failures in the market. So all of these faulty units were returned to a central repair facility, and they were repaired, and it was found that one of the ICs, it didn't look right, and they realized that the IC was actually a counterfeit IC. So, you know, it was working, it had a life, but that life was greatly reduced. Maybe it was in the wrong application. Maybe there was something that made it unstable within the application it was used for. So this is a serious problem because, okay, how many other units are out there that have got this counterfeit chip? So the objective for the traceability data was to identify, okay, exactly when and how that counterfeit material came in to the operation. And not only that, because finding it is one thing, but we want to reduce the occurrence of counterfeit in the future. We want to find the responsible party. We want to go to them with some evidence to say, hey guys, you were responsible for this issue. There's no questions, there's no argument, just, you know, be responsible and make sure it doesn't happen in the future. So these were the objectives. So again, they knew the IC was used in many different products, but which ones? And again, they knew that these products were already in the market. So on the next slide, we'll see, again, what happens with different levels of traceability. With no traceability at all, it's a familiar story. 1 million different units of products had to be recalled because they just simply did not know where that IC, the actual counterfeit, was going to be. So major, major problem. Level 1 was significantly better because they were able to, from the IC that was used, they were able to understand, okay, the kind of date range, it was narrowed down, and then we're looking at only 50,000 units. Okay, this is significantly better, but it's still a significant problem. If we were to use level 2 for traceability, then we can pinpoint the actual shipment from which the counterfeit IC came. And then we can look at that shipment and understand exactly where the materials from that shipment were used. And in this example, it only went into 2 products, and therefore the number of recalls was around just over 3,000. So the problem was found. Okay, it's a purchase of reels on the grey market. This is quite a common occurrence, actually, to have to use the grey market, when we have issues for missing materials, and sometimes that can lead us into higher risk scenarios. If we'd gone to level 3 and level 4, then actually the exact area in which this IC was used, which was 1,500 units, now they are the only ones that need to be recalled, because in this case we used unique reference level identification. So maybe the products had been on a machine where there were 2 alternative materials set up. In level 2 we didn't know which one was being used, but in level 3 and 4 we knew exactly which reel was used for each of the occurrences of that chip. So again, an illustration that the higher level you go, the more granularity you have when it comes to sorting out quality issues. If we go to the next slide, this is kind of a very important thing again for counterfeit, because in the past we've been able to reduce the amount of incoming inspection, which is a very high cost to the operation these days, whilst at the same time the general quality of materials has improved, and so we see quality improving a huge amount. Recently, however, the trend is going backwards. The trend is that we now don't trust the materials coming in so much. Once we've seen a counterfeit, you kind of want to test everything. And that increases cost, it increases delay, it increases the stock you need to keep. It's going back to the 80s. It's not a good idea. And so here is where the critical level 2 plus of traceability is really going to make a difference. Because people will know that if any counterfeit material comes into the operation, when it's detected, to be able to go back, it's like a detective being able to have the evidence to show to the supplier to say, hey guys, you are responsible. Then they realize that, okay, it's pointless trying to do this again because we're going to get fined, we're going to get excluded, some kind of action is going to be taken. It's going to damage our business if we allow this to continue. So it may have been the company that's responsible, it may be one of their subcontractors. They need to have traceability all the way up to be able to find out that cause and eliminate it. When that happens, counterfeit reduces. Until that happens, we end up paying more and more and more. So traceability level 2 is absolutely essential in these cases to be able to have that accountability for the counterfeit coming into our operations. Okay, on the next slide, we have a conclusion that, we've talked a lot about IPC-1782, the kind of technical approach, the business approach. This is really, and for me it was a big surprise, one clear standard for the whole industry. We've not had that before. We've had little bits of pieces where people were confused, arguing about what should and should not have been collected, the cost for collecting all of that. It was just a mess. Now with IPC-1782, it's a clear standard. And it's not just one level. There are appropriate levels for every kind of scenario within manufacturing. Start from something more reasonable, something that matches the operation today, and aspire to get to higher and higher levels of quality. It may be driven by market needs, product branding, counterfeit, whatever it may be. Maybe just increase the level of quality. Whatever it is, you're able now to increase that level without increasing the costs that we had before, because now we are collecting data in a more automated way. So realizing these benefits actually in terms of insurance, assurance and quality You think about the benefit that comes from that, the reduction in the amount of money every day for quality, occasionally for assurance, and we hope never the insurance aspect. We never want to have a recall. But you put all of that saving of money together, and you realize that traceability isn't a burden to the industry anymore. It's not something you have to just pay out for. Really, you can get a lot of benefit, actual operational benefit from the use of the traceability. And so now we see traceability as being of value to the industry. And that happens with IPC 1782 because it is the one standard for the whole industry. Okay, so from the next slide, we'll be taking some questions and comments if anybody has them.
So, Michael, the only thing I would add to that, this is Cameron Sharon from AT&T, the only thing I would add to it is that the idea for this standard was, I thought about it in 1999, but really the cost to implement it was prohibitively high because a lot of the traceability technology in the pick and place machines and so forth really didn't exist. Whereas, like Michael said today, it exists, and so it really comes at the right time to leverage the existing technology that's out there, and the incremental cost to add those capabilities to new pieces of equipment is relatively low. It's 10% or less.
So Michael and Cameron, I actually have one question, and this goes to the development of the standard. Can you think of any sort of sticking points that came up during the development, and how the task group worked to resolve those to come to some sort of a consensus approval?
Okay, I'll answer just first. For me, the interesting thing was to go through the requirements of what data to collect from each of the different machines. Because, you know, there are machines on the market that provide a lot of data, and there are some that provide a lot less data. So case by case, we're going to have different experiences in what kind of data can be collected. And for a lot of the people on the committee, this was kind of driving the decision of what data elements should be appropriate for each level. So, for example, somebody would say, you know, I want the opening time of the paste to be level 2. Whereas they'd say, well, actually, for us, that's not so important. You know, we'd prefer to see it level 3. We don't want to be forced to do that if we're on level 2. It's not adding value, or it's difficult to do. And so those were the kind of discussions, I think, that took up the vast majority of the time, actually. We were quite careful. I mean, it's not going to be absolutely perfect for everybody, and certainly not in the first version, but you know, we wanted to make sure that all of the requirements that we put for each of the different levels were going to be appropriate for the expectation of what traceability was going to be used for at that level, but also going to be in keeping with something that's practical, that is available from the process without having to do an extra task, which would incur extra money.
Yeah, and I would say that I would agree with that. That it really wasn't a sticking point. It was more along the lines of that we had a nice, robust group from a variety of perspectives, and we wanted to be have very thoughtful solutions, being very mindful of, you know, all the concerns that we've heard, you know, over time, as well as in contrast to the chronic and acute needs for this level of information that have existed over time. And so the only other point of discussion, really, like I said, what really wasn't a sticking point, but where we had a lot of discussion, where we reached spent a lot of time to reach a consensus, was on the chart to go from the traditional IPC levels to the traceability levels that we have in this standard.
Yes, that's true. Yeah, I think the choice of I mean, we chose the 4 levels of material and process, and we kept them separate simply because that seemed to be the practical way to approach things. But then the mapping of those to the classifications that was something that had a lot of discussion. But, I think that we came to a great conclusion on that. And, as we saw in the little table, there are areas where exceptions can be granted. It's easy to start discussing things between a supplier and a company when you have a clear specification about what you're going to do. So I think we came to a very good resolution on that.
Yeah, I would agree with that.
Great. Well, thank you, Cameron. Thank you, Michael. This has been a great presentation, and I think very informative for those who attended. And thank you, everybody, for attending today's webinar. Please watch your email for a link for more information on the IPC 1782 standard, as well as how you can participate in upcoming meetings of the IPC 1782 task group. And that concludes today's webinar. Thank you.
Yeah, thanks very much, everybody.
Yeah, thank you for your time.